Hello everyone, good evening. Welcome back to Wallah English YouTube channel. I hope everyone is doing great. So till yesterday we have started infiltration topic. Today we will move ahead and solve some questions and the important concept of infiltration. Okay, so before starting, everyone kindly comment that I am fully audible and visible to you all. Good evening, Sushil. Good evening. So we have discussed till here. Wait a second. Yesterday we have discussed drought and its types. Okay, we have discussed what meteorological drought is, what is your hydrological drought, what is agricultural drought. Okay, all the kinds of droughts we have discussed. Meteorological drought was when decrease in precipitation is more than 25%. Okay, I have given an example. I have explained it to you with the help of an example of an average Indian annual rainfall. Okay, then what was hydrological drought? Hydrological drought, when this meteorological drought is prolonged, okay, is extended, then level of water will be decreased everywhere, so that is your hydrological drought. And when it will affect the growth of a crops, okay, farms will be affected, then in that case I will call it as agricultural drought, which is basically indicated by a index known as aridity index. Okay, AI is PET minus 80 upon PET into 100. This we have already discussed. This was the table which we have to remember. Okay, from 0 to 25 it was mild arid, from 26 to 50 it was moderate, then severe. Mild, moderate, severe, remember this. And value of index varies from 0 to 100%, you all know this. And then we have discussed what is index of wetness, what is rainfall deficiency. Okay, everyone kindly comment that I am fully audible. Okay, great. Now, so after this we went on to discuss index of wetness, what was rainfall deficiency, and how IMD has classified droughts here. Okay, this we have already discussed. I hope it was very clear to you. After that we discussed interception, we discussed depression storage. Okay, interception, you all know that the water which is unable to reach the ground surface, that is your interception. Okay, depression storage is the volume of water which is trapped in the depressions after rainfall, and after these depressions will be filled, okay, then your water will start running off. I hope this is clear. Great. So after this we went on to discuss infiltration. Yesterday we have discussed what is infiltration and what is the effect of infiltration. Okay, you all know that infiltration will replenish the soil moisture and recharge the groundwater. Then I discussed about all the losses: evaporation, transpiration, interception, depression, infiltration, storage. See, out of all these losses, I told you which is the major loss. If a severe storm is there, if a major storm is there which is capable of producing a flood, then which one is the major loss? Infiltration. Okay, I told you this thing. So we will ignore all these, and instead of losses I will only consider infiltration. Okay, this is not the rule. Obviously you can consider the other losses, but yes, if you want to simplify it, so simple assumption we can take that all the losses can be equated to infiltration, and we will neglect the other you can say minor losses, so that our equation gets simplified. Yes or no? Perfect. Then we went on to discuss the factors. Okay, we discussed infiltration is affected by the characteristics of soil. Infiltration is also affected by condition of soil surface. Okay, see, I told you that coarse soil gives you more infiltration. Then vegetation cover, when vegetation cover is more, then also infiltration is more. For low viscosity water we have more infiltration because it is thin, so it will easily penetrate. Yes or no? Then we went on to discuss about rainfall characteristics. In rainfall characteristics, I told you this was the last point, I guess, which we have discussed yesterday. Okay, see, whenever we have more intensity of rainfall, okay, you have to remember this thing: whenever we have more intensity of rainfall than your infiltration capacity, then in that case, sir, some water will go into the ground, and the remaining water, the excess water, the excess rainfall, or see, this term is also known as supra rain. See, the extra rainfall here, this extra rainfall will become a part of runoff. Okay, this extra rainfall will become a part of runoff, very important. But when you need to understand one thing here, but when intensity of rainfall is less, then in that case what will happen? All the water of rain will go inside the ground. If intensity is less than the maximum absorbing capacity of your ground, in that case runoff will be zero. So I hope this thing was clear to you. Now we'll move ahead and we'll discuss in today's class how we measure. Okay, how we see. Before starting measurement, I told you that when we have discussed evaporation, okay, see, in evaporation I already told you that in evaporation, firstly what we did, firstly we understood what is evaporation, then we went on to discuss the Then we went on to discuss the factors. Here also we have discussed all the factors. Okay, these were the 5 factors we have discussed. Then we went on to measure. Then we went on to measure evaporation. Similarly, here we are also going to measure infiltration. How we will measure? Let me tell you. Okay, today we are going to basically discuss about measurement of infiltration. Is this thing clear? Today's class basically will be based on measurement of infiltration, which is very important topic. Okay, it's one of the most important topics of your GATE examination. Infiltration is very important topic. So how we measure basically, sir? Sir, tell me how we measure infiltration basically. So obviously, see in evaporation, I told you that evaporation is measured by evaporimeters. Yes or no? I told you that thing. Yes or no, everyone? Yes or no? Everyone kindly comment. In evaporation, I told you that we measure with the help of evaporimeter. Here we will measure with the help of infiltrometer. So the very first method of measurement is we have infiltrometers. Okay, we have different sorts of infiltrometers. Okay, we'll discuss basically 2 kinds of infiltrometers that I will show you. We'll discuss 2 kinds of infiltrometers. The first one is flooding type. The second one is rainfall simulator. I will show you the diagram also. No need to worry. After infiltrometers, we have certain empirical equations also. Okay, after infiltrometers, we have certain empirical equations. So that we have to discuss. So infiltrometers is there, then your empirical equations is there. Okay, see in empirical equations, Horton equation is the most important one. Horton equation. Let me tell you that in this infiltrometer thing, wait a second. Let me tell you that in this infiltrometer, we have 2 kinds of infiltrometer. The first one is flooding type. Okay, flooding type infiltrometer. The second one is rainfall simulator. The second one is rainfall simulator. Okay, then empirical equations, only one. See, many equations are there, many scientists have performed many experiments regarding infiltration, but one is the most dominant one and the most popular one. Okay, so which is that one? That is Horton's equation. Horton is most important. This time also in examination question have been asked, so Horton's equation we have to understand. Now what see, now we will discuss basically first infiltrometers, then empirical equation. So in infiltrometers we have 2. The very first one which you can see here is flooding type infiltrometer. Okay, I will tell you. So one doubt is here. Okay, this series is not showing, so this cannot be the case, dear. See, when you will go to the app, okay, there you have to search, there you will get this PPT, okay, easily. Otherwise you can get this PPT on my Telegram channel also. Okay, simply search my name on the Telegram. In that group you can go to the files and there you can get this PDF. Okay, Hydro complete, like this it is, so you can get it from there also. Okay, now we'll discuss the flooding type infiltrometer now. Okay, now we'll discuss flooding type infiltrometer. So you can see this is an infiltrometer. Okay, so what is done here basically, let us say we have a ground here. See, this is your double cylinder. Okay, single cylinder is also there, double cylinder is also there. I'm showing you the I'm giving you the example of double cylinder here because this is more popular. Okay, obviously I'm going to tell you the more popular one. So let us say we have a ground, we install it in the ground itself. Okay, we install it in the ground itself. Okay, like this. Let us say this is the ground and this is the cylinder. We have installed it into the ground. Yes or no? Okay, sir. See, since this is a double cylinder, I have to make it like this. Okay, you can see it here. The actual image is this one and this one is your diagram. Now what I will do, see, this cylinder is basically open. This cylinder is basically open from the bottom. This cylinder is open from the bottom. What does it mean, sir? When I will fill the water, see, they have filled the water here. Can you see this water? I hope the water is clear to you in the diagram. Yes or no? We will fill the water here. Okay, we will fill the water here. We will fill the water here. Okay, now obviously you all know that whatever water we have, should I remove this or not? Okay, no problem. Let it be here. So let us say we have filled some water here. Okay, we have basically flooded. You need to understand one thing. We have basically flooded the uh, land mass in this meter itself. We have flooded it with water. That's why it is known as flooding. Okay, now what will happen? Now what will happen? You need to understand one thing here. You need to understand one thing here that, sir, this water level will decrease. Why? Because this water will infiltrate with passage of time. You need to understand one thing, that this water will seep into the ground slowly and steadily. Okay, with passage of time this water level will decrease. Why? Because when you will give it time, some water will infiltrate, and you are here only to measure the infiltration rate only. So let us assume that in let us say in one day 5 centimeter water has depleted. So obviously we'll come to know about the rate of infiltration. That means, sir, 5 centimeter of water has been infiltrated every day. Yes or no? So the level of water which will be dropped here, that is 5 centimeter per day. But you know, one problem is there. Can you guess the problem? What is the problem in this one? The problem is, sir, that in flooding type infiltrometer there is no rainfall. Sir, we can see you have simply flooded the water. You have simply flooded the water and there is no rainfall here. There is no rainfall. Okay. You need to understand that in actual practice, infiltration occurs when rainfall is there. Yes or no? Tell me. Yes or no? So that you have to understand. Okay. So we need to understand one thing, that actual rainfall is not there. So obviously the value of infiltration which it will give will be little different. Second thing is, you need to understand, when I will try to install such kind of meter here, you need to understand that soil fabric, okay, the soil which is there present there will be disturbed. Now if soil is disturbed, tell me the infiltration rate, okay, the infiltration capacity will also be changed. Yes or no? So these are some drawbacks here. Okay, let me write the drawbacks here in the space which is left here. Let me write it here. Okay, what are the disadvantages? What are the disadvantages here? Disadvantages here. Okay, so the very first disadvantage is that when this flooding time is installed, the soil fabric is disturbed. Basically I will write soil fabric is disturbed. Soil fabric is disturbed during installation. Obviously that disturbance will change the infiltration capacity, okay, of soil. So soil fabric is disturbed during installation. Hence infiltration capacity changes. Second thing. So this is the first drawback. Second point is, sir, you have told me that no rainfall is here. Yes or no? No rainfall is there. So I will write here, sir. Sir, actually this flooding type infiltrometer is measuring infiltration, but in absence of rainfall. So obviously when rainfall is there, see, I have told you one thing, sir, that whenever we have, let us say we have a open land here, okay, and when rainfall will be here, obviously that rainfall will impact the ground. That rainfall will hit, or you can say will hit against the ground, and obviously soil compaction will be there. And because of soil compaction, sir, these voids will get you need to understand the voids will get closed. They will get closed and the void size will become smaller. So obviously in that case infiltration capacity will be less. Yes or no? Infiltration capacity will be less. So whenever rainfall is there in actual practice, or whenever rainfall is there, in that case, because of raindrop impact, you will see, sir, that less water goes inside because void size decreases. But here, sir, you need to understand, in actual practice, this flooding type infiltrometer will give you more infiltration. Why? Because no raindrop impact is here. Because if raindrop impact is here, then infiltration will be less. So obviously the value which it will give will be more. The value of infiltration which this will give will be more. Yes or no? Kindly comment everyone. Kindly comment. Kindly comment once. Is this thing clear? See, if they ask you in exam, like flooding type of infiltrometer will give you more value of infiltration or less value. So what you will say? Yes, Priyansh, you can ask your doubt, no problem. What you will say? I will say, sir, that flooding type infiltrometer will give me more value as compared to infiltration in actual rain. Okay. So I will write this point here. That it does not simulate, it does not simulate, it does not simulate the effect of, it does not simulate the effect of rainfall. Okay. It does not simulate the effect of rainfall. So obviously it will give you different infiltration capacity. Okay. Now, what is the solution to this? How this can be improved? So we have a better infiltrometer. I hope this is very, very clear to you. Okay. In this infiltrometer, flooding type infiltrometer also we have various types, but that's not so important. Okay. Now, okay, now flooding type is done. The second one which we have to discuss is rainfall simulator. As the name tells you, rainfall simulator. Can you guess why this rainfall simulator is better? Can you guess? See, just now I told you that in flooding type infiltrometer, the biggest drawback was that it is measuring the infiltration in absence of rainfall. This is the biggest thing. Sir, it is measuring your infiltration in absence of rainfall. So what we have done here, we have simulated an environment. Okay, we have simulated environment similar to rainfall. Okay, what I will do here is, listen very carefully. Okay, what I will do here is, we will take a very small plot of land. Basically, we will take let me write here. First, let me explain. So we will take a small plot of land. Okay, sir. Then in that small plot of land, what I will do, here is, I will provide series of nozzles here. Okay, I will provide series of nozzles, and from these nozzles, artificial rainfall will be produced. What will be produced? Artificial rainfall. That rainfall will drop in this area. Okay, and it will simulate the effect of artificial rainfall, which will be falling from a height of 2 meters, and then obviously after some time you will see infiltration is there, and that will be measured. Okay, so with the help of water jet equation. So you need to understand that this rainfall simulator thing is better. Why? Because it creates or replicates the exact environment as that of actual rainfall. Yes or no? So this is better. If some, acha, one question is there. Let me ask one question. Can you guess which will give you more value of infiltration? Rainfall simulator or flooding type? Can you tell me the answer? Which will give you the more value of infiltration here? Just guess it. Okay, sir. Right to go with a supervised before. Priyansh, you are asking one question. See, if you want to go for that exam which you are asking, so obviously for that you need to understand. See, the level of these exams have increased these days. Okay, so for that you have to prepare for engineering services objective part. Okay, see, I have cleared that exam only because I have prepared for engineering services once. Yes or no? So you need to understand, Priyansh, that you have to cover your engineering services objectives religiously. You have to cover this. Okay, all the PYQs. Apart from that, you have to cover the content of you need to cover the content of AJE. Okay, so those batches will obviously help you. In covering all the content of AJE. But yes, you have to put some extra efforts on covering the engineering services objectives. Okay, with that content also you can solve it. Okay, I hope the concept is clear to you what I'm trying to explain here. So never settle with less preparation. Okay, because the students which are giving, students who are preparing for that examination are also have also prepared for engineering services. Okay, so I hope you have also prepared for engineering services and gate once. Okay, then no problem in that batch. Okay, I hope the things are clear to you now. Sushil is saying, sir, less value due to compaction of soil voids during installation in comparison to natural soil voids. Yes, 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 dear. So you have to prepare for, you have to prepare big. Okay, you have to prepare big. You have, if you will cover for engineering services, and obviously all the exams will be covered easily. Yes or no? So now, what is rainfall simulator? Yes, so I told you about the rainfall simulator thing. Okay, I told you about rainfall simulator thing. So what is rainfall simulator? Yes, so a plot of land is there, a plot of let me write little theory here. So plot of land, a plot of land 2 meter by 4 meter, a plot of land 2 meter by 4 meter, a plot of land 2 meter by 4 meter will be installed, will be installed with series of nozzles, with series of nozzles which will produce, which will produce, which will produce artificial rain, which will produce artificial rain falling through a height of, falling through a height of, falling through a height of 2 meter. Okay, falling through a height of 2 meter. So this is your rainfall simulator thing. So I hope this is very clear to you. But obviously this will give you better results. This will give you better results. Yes or no? Perfect. Great, dear. Great, yaar. Great, Priyansh. So let's move ahead. So I've asked you one question. You haven't answered it till now. I've asked you one question. See, I told you we have two infiltrometers here. One is flooding type. The second one is rainfall simulator. So tell me which will give you more value and which will give you less value. Tell me which relationship will be correct here. See, this question is saying the infiltration capacity of soil was measured under fairly identical conditions by a flooding type infiltrometer also and by your rainfall simulator also. The value of infiltration which they have experienced with flooding type infiltrometer is FF, and the value of infiltration which they have received using rainfall simulator is FR. So which will be more or which will be less, or both will be equal? Can you guess it? Or no fixed pattern is there? Which option will be correct here? Try to guess it, everyone. Let me see if you are able to answer it correctly. Tell me what will be the answer here. Now I think you can guess it. See, because of rainfall, you need to understand, because of this rainfall thing, compaction is there, and because of compaction, you have to understand, because of compaction, soil voids will decrease. When void size will decrease, obviously less water will go inside. When less water will go inside, so obviously infiltration will decrease. Yes or no? Is it tough? Is it tough? So obviously rainfall simulator will give you lesser values. So A option will be correct. I hope this is clear to you. This is very simple. It's not that tough. Okay, now we'll move ahead. So infiltration capacity, A option is correct. You are absolutely guessing it correctly. Let me write one point here. This will give you, this instrument gives better results as it simulates, as it simulates the effect of, as it simulates the effect of actual rainfall. Yes or no? Perfect. As it simulates the effect of actual rainfall. So this is clear. I have understood the meters. Now what we are going to discuss is, we are going to discuss Horton's equation. Okay, So I have told you about the infiltrometers. These two are very, very clear to you now. I have shown you the actual images also. Now we'll discuss empirical equations. See, many scientists came up with different equations. Many PhD works have been carried out on infiltration. Okay, many data, too much of data is also available. But yes, you are saying when this will be in Hindi. See, if you want to study this hydrology thing in Hindi, this will be coming up on your that gate wala MECE channel. Okay, that is for Hindi students. This is for purely English students and the students who are hailing from south, so no need to worry about that. Okay, so you are asking it Hindi. If you want to study in Hindi, you have to go to gate wala MECE channel. Okay, now we'll discuss empirical equation, Horton's equation. So now what is Horton's equation? So now we have to discuss today's lecture. In today's lecture, basically, we'll focus on Horton's equation only. See, Horton's equation is very, very important equation, and the scientist was Robert E. Horton. Robert E. Horton. He came up with a brilliant idea. Actually, he modeled infiltration. Okay, he modeled infiltration, and according to his findings, what he told. See, first you have to understand one thing. Before starting this topic, let me explain it to you. The beautiful concept of infiltration capacity. See, I'm asking you one thing. I am just asking one thing. Let us assume we have a ground here. Okay, sir, we have a ground. In this ground, on this ground, let us assume rain is happening. Okay, rain is falling. Now tell me, can you just guess? Can you just guess that infiltration capacity of this ground? See, what is infiltration capacity? I have told you the symbol for infiltration capacity as FT. Okay. See, FT is denoting infiltration capacity. Now, what is the meaning of infiltration capacity? Sir, you told us that infiltration capacity is maximum rate. Listen very carefully here. Okay, otherwise you will get confused. And this is very important concept because this will be asked in your gate examination. I am marking it star here. Okay, what is the meaning of star? That it can be surely asked in gate examination. It's very important. Very, very important. Okay, now. So what is infiltration capacity, sir? It is the maximum rate at which your ground can absorb water. Maximum rate. Let us assume that when rainfall has started, in the starting, initially, let us assume that infiltration capacity was 5 centimeter per hour. Let us assume infiltration capacity at the start of rainfall, in the beginning of rainfall, is 5 centimeter per hour. So tell me, I have a simple question for you. Tell me, will this infiltration capacity, will this maximum rate of absorption will be same during the rainfall, or will it increase or decrease? Can you guess it? Tell me, can you guess it? Can you tell the answer? Tell me, everyone. Obviously, you need to understand, initially your ground is dry. Initially your ground is dry. When it will continue to receive rainfall, it will get saturated. The voids will be saturated with passage of time, yes or no? So obviously with passage of time you will see that the maximum rate at which your ground can absorb moisture will decrease with passage of time, yes or no? You are guessing it absolutely correct. With passage of time, your ground will absorb or infiltrate less amount of water. So this is the ultimate finding of Horton. But one thing is that he carried out certain experiments. Okay, he modeled this entire experiment and he came out with brilliant. See, the thing is, sir, how fast this rate will go down? You are saying that this will decrease. Yes, sir, but I don't know, sir, will this decrease linearly? Okay, sir, will this decrease in parabolic fashion or logarithmic fashion or exponential fashion? Sir, how this will decrease? Okay, sir, will it decrease in a linear fashion? Sir, will it decrease in a non-linear fashion? So that we have to understand. So for that, Horton, brilliant scientist, he carried out many studies and he came up with the idea that after too much of experiments, he concluded that your infiltration capacity decreases exponentially with time. Okay, he came up with an idea of exponential decrease. So I will write here that according to Horton, infiltration capacity decreases exponentially. Okay, decreases exponentially with time, exponentially with time. So this is the ultimate finding. Let me show you the graph now. See, this is very important. Please stay focused. Okay, very, very important equation this is. So it's a request that you all stay focused. I will tell you the equation also. But first, let me draw the graph. On the graph, I will show you how this thing works. So on the y-axis, I will have infiltration capacity. And on the x-axis, I will have time. Yes or no? On the x-axis, we will have time in hours or something. And here I will have infiltration capacity. Infiltration capacity is denoted by Ft. Okay, I have already told you this thing is denoted by Ft. Now, so this according to this equation, according to Horton, it drops down exponentially. So let us assume that when your time t is equal to 0, at that time let us say the infiltration capacity of ground is F naught, highest. Obviously it will be highest in the beginning. Okay, we call it F naught. Yes or no? See, you need to understand one thing, that this infiltration capacity unit will be basically centimeter per hour. Yes or no? Unit of infiltration capacity generally it is mm per hour, centimeter per hour, like that. Okay, now sir, this is going down exponentially. But one thing is there, that after certain period of time, sir, this decrease. Okay, it will decrease to a constant value, and after some time it will become constant. Okay, after long duration of time, sir, this will become constant. I hope this is clear to you. Yes or no? So this will become constant after certain period of time. This will become constant, and that constant value will be denoted by Fc. I hope this thing is clear till now. Okay. Now he gave a relationship. That if you want to find infiltration capacity at any time t, if you want to find infiltration capacity at this time, let us say you want to find at t equal to 1, let us say if you want to find at t equal to 2. So if you want to find infiltration capacity at different times, which is changing, sir, infiltration capacity is changing with time. So if I want to find it, how I will find it? So I will use Horton's equation. According to Horton, he gave an equation with the help of which we will be able to find infiltration capacity that is changing with respect to time. We'll put the time in that equation and we'll find infiltration capacity. But sir, what is the equation? Now, if you want to find a point on this curve, if let us say if you are interested in finding this point, okay, can you guess the coordinate of this point? So if you want to understand, if you want to write the coordinate of this point, let us say it is having a coordinate of t here. Okay, we are interested in finding the value of infiltration capacity at time t. So obviously this coordinate will be t. You all know that x-axis is written first, abscissa is written first, then your ordinate. Then I will write ft. So this is t comma ft. But sir, how I will find ft? So according to Horton, he gave an equation. ft equals what? This is ft. Listen very carefully. See, ft is fc plus something. See, this is ft. This total thing is ft. Yes or no? So this is ft. This is fc plus something. So I will write fc plus. Now what is this? See, you need to understand this gap is f naught minus fc. This gap is f naught minus fc, and this gap f naught minus fc is decreasing exponentially. Okay, so I will multiply it by exponent. Okay, e power minus kt. What is k? K is Horton's constant. Obviously k is your Horton's constant. Very important equation. So you need to understand, if you want to find infiltration capacity, okay, if someone asks you like what is ft, you will say that ft is infiltration capacity. ft is infiltration capacity at any time t. Simply in this equation, put the value of t get different ft. Put another value of t, get ft. See why I have written t here. I have written t here only because infiltration capacity is a function of time. This you have to understand, okay? Yes, Rahul, obviously both are different. Yes, both are different thing. See, storage capacity, that is different part. Okay, how much you need to understand. Let us say we have a bowl here. Okay, and on the bowl at the top, let us say we have a perforator. Okay, and let us say rainfall is happening. So some part of rainfall will infiltrate through this, through these perforations, through these openings. So obviously the part of rainfall which is perforating or going down through these small openings, that will be different thing, that is infiltration. And the water which will be collected in this bowl, that is storage part, that is the amount of water which is stored in the soil. So this is different, this is different, infiltration is different. Obviously, yes, one thing is for sure, that whatever water will store, whatever water will infiltrate, ultimately that also has to store there. Okay, whatever water will infiltrate, obviously that will be also a part of storage. Yes or no? So final storage will be what? Initial storage plus infiltration. Obviously infiltration will increase the storage of your soil moisture. Obviously the capacity will be enhanced, which will be used up by the your crops. Okay, so I hope this thing is clear. Oh no. So this is your final equation. Now, so I hope this is clear. See, this is FC plus this. So this is FC, this is FC, and this is F naught minus FC e power minus KT. So we have added the two terms. So whenever we'll add two terms, we'll get at different times we'll get the different value of FT. Okay. So I hope this thing is clear. Now we'll discuss what is FC, what is F naught. Sir, F naught is nothing but initial F naught is nothing but initial infiltration capacity at time t equal to 0. At time t equal to 0. Sir, initially F naught is the highest value, that maximum rate will be maximum. Yes or no? Okay. Now, what is FC? What is FC? Sir, FC is the constant value, but that constant value has been achieved by ground after long time. Okay, after rainfall has ended, or let us say after 8 hours or 10 hours, this value will be achieved. Okay, because you need to understand that after some time, see what happens. Basically you need to understand, see, let us say this is your soil. Okay, let us say this is your soil fabric. Okay sir, below this no water will go, or let us assume this is a semi-infinite medium. Semi-infinite means that this is continuing endlessly. Okay, now rainfall is happening. Initially too much of infiltration is there. Okay, initially let us say too much of infiltration is there, and obviously you need to understand that whatever water is going, see, soil is dry now. Soil is dry, which means that all the voids are empty initially. So what will happen? Some water will be stored in the voids. Some water will be stored in the voids initially when this rainfall has started. Some water will be stored here, and some water will go down. Yes or no? Now, with the passage of time, since these voids are getting filled, you need to understand, since these voids are getting filled, now less water will go inside, because initially all the voids are empty. Sir, initially all the voids are empty, so more water was going inside. Now after some time, sir, what has happened here, that why this is going down? Because some voids have been filled. With passage of time, sir, I will see that all the voids in the top soil will be filled completely. They all will be saturated. All of the voids will be saturated if your rainfall continues for long time. This means after certain period of time, sir, what I will see, that all these voids are completely filled. Okay, now what will happen? So after certain period of time, sir, we will see that all the voids will be filled. Now whatever rainfall will happen, it will come inside. Some water will be, okay, see, these this will be completely saturated every time. Some water will move from here. Listen very carefully. Now a steady state will be reached. Now an equilibrium state will be reached, where you will see that whatever water is entering from here is leaving from bottom here. Okay, so water will be continuously coming from here, and it is continuously going from here, but you will see that no storage of water is there in the voids, because all the voids are already saturated. Yes or no? So whatever water will come, that will go here and join the groundwater table. Okay, whatever water will come will percolate deep down and join your groundwater table. So steady state will be reaching after certain period of time, when your all the voids here, all the voids will be saturated. But initially when your voids are not saturated, at that time storage, or you can say your soil moisture is being replenished or recharged initially. Okay, so after certain period of time, water will come, infiltration will take place. Whatever water will come, infiltration will take place at a constant rate. Okay, and the remaining water which cannot go inside will be running off. Okay, so let us say 2 centimeter per hour is the constant rate, which means 2 centimeter of infiltration is happening, and that 2 centimeter is leaving and joining the groundwater itself. I hope this concept is clear to you. So because of saturation of all the voids after certain period of time, you will see that this constant phenomena will happen. Okay, so this FC thing is constant infiltration capacity This is constant infiltration capacity after long time t. After long time t. Okay. Is this thing clear? Okay, Vishal sir. Dear, I don't have any idea. Okay, so he's from different branch basically, so I have no idea whatsoever. Okay, so I have no idea, otherwise I would have told you definitely. And also he's not from civil branch. Basically I'm in touch with civil faculties. Okay, so I hope you can understand this thing. So this is your basic equation. Now one more thing is there, K. Okay, K thing is also there. What is K? Sir, K is Horton's constant. K is Horton's constant. K is Horton's constant. Okay. What is Horton's constant? Horton's constant, you need to understand. See this exponential part, e power minus something, e power minus 5t, 4t, whatever it may be, that is our constant here. And this constant thing depends on what kind of soil you have. Okay, see, some soils obviously will you need to understand, some soils will draw more water, will absorb more moisture or water, yes or no? So based on that, see, graph can go like this also, graph can go slowly also, graph can go in moderate way also. So obviously if we have different characteristics of soil, okay, different fabric of soil, different texture, then obviously this K thing will vary. So this K varies with type of soil. Okay, its unit is per hour. Basically it is R inverse or time inverse unit. R inverse, see, the unit of F0 FC is centimeter per hour. This will be expressed in centimeter per hour. Now we'll solve some question. Also one more thing you also have to understand. Okay, one more thing you also have to understand, that if I want to find total infiltration, this thing is very, very important. Okay, see, if you want to find total, see, the equation to this curve, ft versus t is given to you. Okay, see, this is very most important, one of the most important equations of a hydrology. I hope it's very, very clear to you. Okay, so this equation part is very, very clear to you, I hope. Now if you want to find, now in question they are saying find how much infiltration has taken place from 1 hour to 2 hour. They are saying, tell me how much total infiltration has happened during 1 hour and 2 hour, between 1 hour and 2 hours. So what I will say, sir, I will simply integrate this area. I will simply integrate and find the area under this curve, so that I get the total infiltration which has taken place during this duration. Yes or no? See, one thing is for sure, that if this infiltration capacity was constant, let us assume if this infiltration capacity was constant, but yes, It is not constant. Obviously, we can see that it is exponential decreasing. But let us assume if it was constant, then, and they are saying, find the infiltration capacity in the first 2 hours, and this value is 5 centimeter per hour. So can you guess? So can you guess in 2 hours how much infiltration will be there? So I will say that total infiltration will be ft. Ft means infiltration capacity, which is constant, into time. Yes or no? Total infiltration will be 5 centimeter per hour. Every hour 5 centimeter water is going to the ground, and we will multiply it by 2 hour. So that total 10 centimeter of infiltration takes place. So that total 10 centimeter of infiltration takes place in this time duration. So when your graph is constant, you will simply find the area. When your graph is constant, you can simply find the area using area of rectangle. Okay, but here you can see we have a curve, and if you want to find the area under the curve, then what I have to do is I have to do what? I have to do integration. Okay, let us say they are saying find the total infiltration during the first 5 hours. So this is 5, this is 0. You have to integrate from 0 to 5. So is this thing clear? So simply sir, you are saying if you want to find the total infiltration depth, if you want to find the total infiltration, sir, if you want to find total infiltration F, that too in centimeter, so what I will do, sir, I will do integration from time t1 to t2 ft into dt. Okay, what I will do here is I will take a simple sir, I will take a very small strip here. This is your small strip, and this will be okay. I will take a very small strip here of length dt. This is a small strip of length. Obviously the length of this is dt. I hope it is clear to you. So the area of this strip will be dt into ft, and then I will move this strip from time t1 to t2, and you will get the area thing. Okay, okay dear. Now we'll solve one question with the help of which we'll be able to understand this clearly. So this is your total infiltration. So let us solve one question with the help of which we will be able to understand this. Okay, now tell me, we have a question here. Try to solve it. Let us have one question which can be asked in your examination. So let us assume Horton's infiltration equation Horton's infiltration equation is given as ft equals, try to solve it, everyone take out your calculators, 6 plus 16 e power minus 2t. Okay, where ft is given in, this ft thing is given in mm per hour, ft is in mm per hour, and this time thing is in r, and time is in r. Now what you have to find? Is 3 to 4 parts I will solve, with the help of which the entire concept will be clear to you. Okay, so let us say we have a ground, and on that ground, let us say we have found out the Horton's equation, which is coming out as ft equals 6 plus 16 e power minus 2t. So ft is in mm per hour and time is in hours. So tell me, what will be the value of evaluate first part? What will be the initial infiltration capacity? You have to find f naught, you have to find fc, you have to find Horton's constant, then find total depth of infiltration then find total depth of infiltration after yeah, or you can say for the first 45 minutes, then find total depth of infiltration for the first 45 minutes, and in the last part, find total depth of infiltration, for the first 75 minutes. Okay, so now we'll solve it. Tell me if you are able to solve it, then I will tell you. I'm giving you 1 minute's time. Try to solve it. Okay, Sushil, no problem. Tell me what will the answer here. So how we'll solve this? See, this is a simple question. Nothing tough is there. So this equation is given to us 6 plus 16 e power minus 2t. You have to compare it with this. Okay. You have to compare it with our equation. From there you can find. Okay. I will also solve it in our calculators. Yes, FC equals 6. That is sure. Now tell what is F naught. Okay, yes. F naught is 22, K is 2. Great. Now find the second part. Yes, you are absolutely correct. Now you have to do integration thing. Great, Sushil. Yes, great. You are doing it absolutely correct. Tell me the total depth of infiltration for the first 45 minutes. On comparing this equation, Ft equals 6 plus 16 e power minus 2t with Ft equals Fc plus F naught minus Fc e power minus kt. Kt or kht. Okay, k is having a subscript h. H means hot and air. Okay, so when you compare it, Fc is 6, F naught minus Fc is 16, and k will be 2. So on comparing, Fc is 6. You can tell this. Okay, we have one more question. No problem. So on comparing this, Fc will be 6 mm per hour. F naught minus Fc is 16. You all know Fc is 6, so F naught will be 16 plus 6, 22. And K will be K will be 2 per hour. K will be 2 per hour. So this is the first part. This is the first part. I hope it is clear to you all. Now, the second part is we have to find the total depth of infiltration. So we have to integrate from 0 to 45 minutes. Okay. See, this is saying, let us say, let us assume this is your equation. Okay. Let us assume this is your equation. This is going like this. Okay. Can you guess what is this value? Can you tell what is this value? Sir, this value is F naught. F naught is 22. So this value is starting from 22 and it is becoming constant after certain period of time, which is 6. Okay. This value will be 6. After certain period of time, it will become constant. Okay. Sir, you are saying find the total depth of infiltration from 0 to 45 minutes. 0 to 45 minutes. You have to find this area. You have to find this area. Okay, sir. How I will find this area? See, we have to understand one thing. Since in this question, time is in hours. Okay, time is in hours. So we have to multiply. See, one thing is for sure that this 2 is in per hour. So you have to multiply it by time, which is an hour only. So that hour thing gets cancelled. Yes or no? So time should be in hours. So we have to convert 45 minutes into hour. Yes or no? Yes, sir. So how I will convert 45 minutes into hour? Sir, I have to divide 45 minutes by 60, which is 3 by 4 in the table of 15. Okay, 3 by 4. I hope this you can understand. So yes, perfect answer. Perfect. You have to divide it. Now what I will do? I will integrate. So this is the first part. Now what is the second part? For second part, what I have to do? I have to do integration. I have to do integration thing. Okay, so in this integration thing, what I will do? I will integrate from 0 to 3 by 4. As I've already discussed, 45 minutes is 3 by 4 hour only. Ft dt. This you have to do. Ft is how much? Sir, Ft is 6 plus 16 e power minus 2t. This is 6 plus 16 e power minus 2t dt. Integrate from 0 to 3 by 4. Now you all know how to solve integration. You can directly solve it in calculators or you can simply integrate. So integration of 6 is 60 plus 16. Integration of e power minus x is e power minus x same. This minus 2 will be divided here and we'll apply the limits. Okay. We'll apply the limits. Yes or no? First I will put the upper limit. When you'll put upper limit here, 6 into 3 by 4. Okay, this is 16 minus 16 divided by minus 2 is minus 8. This is minus 8 e power minus 2t. E power minus 2 t is 3 by 4. Simply we have applied the upper limit. Okay, we have applied upper limit. Now similarly put lower limit. Lower limit is 0. 6 into 0 minus 8 e power minus 2 into 0. When you will solve this, you are getting it as 18 point. How much you are saying? 18.72. Perfect. 18.72 you are saying. Tell me the unit. Tell me the unit of your answer. It will be in mm. Okay. Everything should be in mm and r. Everything should be in mm and r. Okay. So I will write 18.72 mm. Similarly, now find the third part. Similarly, now find the third part in which you have to do what? In the third part, you have to find the infiltration for first 75 minutes. Okay. So if you want to find for first 75 minutes, if you want to find infiltration for first 75 minutes, how I have to integrate? See, 75 minutes is, sir, 75 minutes is 5 by 4 hour. Yes or no? Or 1.25. 1.25 hours, 5 by 4 hours. Okay. 6 plus 16 e power minus 2t dt. How much value you are getting here? How much value you are getting here? Solve it. Solve it. I am not going to solve it again. I think you can solve it from here. Yes or no? So what value we are getting here? What value we are getting here is, wait a second. No, this value we are getting it as 10.715. We are getting this value as 10.715. Okay. Just now I have solved it. So we are getting it as 10.715. 10.75 mm. Okay, check it again. Check it again. Solve it in your calculators or simply solve it by using simple integration technique. Zero 0.75. Yes, this is 10.75 for sure. Okay, great. I hope the integration part is clear to you. I hope the integration part is clear to you. Similarly, you should find from 0 to 75 minutes. Have you found out your mistake where you are going wrong? Have you found out your mistake? This is not coming out as 18.72. Now, yes, you are saying it to be 14.84. Yes, 14.84. Now you are correct. Now you are correct, Sushil. This is 14.84 mm. This is perfect now. Perfect. So I hope this part, if these type of questions are asked in your examination, you will be easily able to solve it. Okay. So this is simple. Now one thing is there, if they are saying find average depth of precipitation. Okay. Let us say they are saying find average depth of precipitation. Let me add a part here. Find average depth. Average depth of infiltration. Find average depth of infiltration for 1.25, simply for 75 minutes. For first 75 minutes, let us say. So how I will find average infiltration? Can you guess? Can you guess how will you find average depth of infiltration? Oh, sorry, average, not depth, average rate of infiltration. How will you find average rate of infiltration? So sir, it's simple. You need to understand, if I want to find average, okay, sir, if I want to find average, listen very carefully. If I want to find average rate of infiltrations, for that I have to do what? For that I have to divide total depth of infiltration. I have to divide total depth of infiltration by time. Total depth of infiltration of depth with respect to time. Okay, so how I will do it? How I will do it? Listen very carefully. See, you need to understand. Let us say we are going till 75. Wait a second. Let us say we are going till 75. Okay, let us say this is your 75 part. Okay. Let us say this is your 75 thing. Now, you need to understand, let us say this is 45, this is 75. So if, see, this is your, you need to understand that value of f is changing continuously. Sir, value of f is changing continuously. Sir, now you are saying to find average infiltration rate. So average infiltration rate will be the total infiltration which has happened in this time duration. So the total infiltration which has happened in 75 minutes is 14.84 mm. 14.84 mm divided by the total time duration, which is 1.25. When you will divide it, you will get it as, yes, when you will divide it, you will get it as, how much? 11.874. Okay, 11.874. So what is the meaning of this average value? What is the meaning of this average value? Yes, this will be 11.87 something, but meaning of this is, let us say if we have a constant infiltration rate, but obviously this is not true. Sir, infiltration rate is changing with respect to time. It is decreasing, it is changing every second, every now and then it is changing, yes or no? But sir, let us assume let us say we have a constant value, and that constant value is how much? Sir, that constant value is how much? 11.87. Yes or no? So if this 11.87 thing is continuing for, let us say, 75 minutes or 1.25 hours, then the area or total depth of infiltration will be 14.84 mm. Okay, so let us assume that we have a constant infiltration rate of 18.74. So this constant infiltration thing, and actual infiltration will give you the same area. Okay, you need to understand one thing. This is 22, 11 will be somewhere here, 11 will be somewhere here. Okay, 11 will be somewhere here. So this value is F average. If you will continue this 11.874 thing, which is constant, for 75 minutes or for 1.25 hours, exactly in the same fashion, then obviously this area, then obviously this yellow area and this green area will be same. Yellow area and green area will be same. Yes or no? Is this thing clear? So only difference is that average is constant. Average is the constant value, and in actual practice, you need to understand that infiltration rate is changing. Okay, so I hope all the concepts are clear to you. Basically, they will not be able to ask anything apart from this. I hope this is very, very clear to you. Yes or no? So is this thing clear? Tell me if this question is very clear to you. This is most important, one of the most important questions of your entire hydrology. Okay, because this can be asked in your examination. So I hope this is clear. Okay, shall we proceed? Yes, perfect. Now we have one more question like this. Let us see if you are able to solve it. Imagine this is your gate examination and you have to answer these two parts. Okay, quickly solve it. Okay, because we have just now solved the entire concept. Let me see if you are able to solve. Both these parts. Okay, I am giving you 2 minutes time. Give me answer quickly. Okay. Yes, you are saying. Great. No. In the second case, we will obviously take from 30 minute to 60 minute. Okay, not from 0 to 60. Not from 0 to 60. Yes, you are right here. Yes, perfect. See, listen very carefully. See, we have to integrate, we have to find the total infiltration obviously in centimeters. Okay, let us say we have the units. Let us say the units of ft here is in centimeter per hour and time is in hour. Okay, obviously this will be the case. Basically most of the time you will say this is the case. So first 30 minutes means from 0 to half hour. Okay, you have to solve this equation first, and in second case what you have to do, basically is, let me take some space here. In second case basically you have to solve from 30 minute to 60 minute. 30 minute means half hour, 60 minute means 1 hour. Okay, so I hope now the thing is clear to you. Basically sir, we have a graph here, and in that graph sir, what we have to do, first we have to solve till half hour and then we have to solve for the next half hour. Obviously you can see that the area of first half hour will be more. Infiltration in the first half hour will be more as compared to infiltration in the second half. Okay, so this is first and second. So this will be equal to how much? This is 3t plus e power minus 2t upon minus 2. Put the limits, and here you have to put the limits. 3t plus e power minus 2t upon minus 2, how much? Half to 1. So what values you are getting here? So 1.816 and second answer is 1.617. Yes, you are right. You are right. 1.816 centimeter you are saying. Here you are saying 1.617. Great. 1.617 centimeter. So this is perfect. You are giving the absolutely correct. You are giving absolutely correct answer here. So I hope the concept is clear to you. I hope the entire concept is clear to you. So this is it. So I hope from now onwards you are able to solve such kind of questions which are based on your Horton's equation. Okay, these are very important questions. They can be directly asked in your examination for 2 marks or 1 marks like that. So I hope this is very, very clear to you. Okay. Now we have to find one more question. We will see one more question here. Tell me, the infiltration capacity of a soil was found to be 6 centimeter hour before rainfall. See, this is another beautiful question. This type of question has been asked in GATE examination in this year only, in 2023. Exactly the same kind of question. So this is important because if this question has been asked in this examination, so obviously it is important for upcoming years only. Okay, so we'll see. So first let us write down the data. Which is given to you in the question. So this question is saying the infiltration capacity of a soil was found to be 6 centimeter per hour before rainfall. See, before rainfall, infiltration capacity is 6 centimeter per hour, which means this is F naught. F naught is initial infiltration capacity. Yes or no? F naught is initial infiltration capacity. So this is F naught. This is F naught. So F naught is given to me as 6 centimeter per hour. Okay, first line is clear to me. Then it was found to be 1.2 centimeter at the end of 8 hours of storm. This is 1.2 centimeter per hour, which means you need to understand that this graph will go down, and after a long time, after 8 hours, 8 hours is a huge time. Okay, so when it comes to rainfall, obviously for rainfall, you will witness that no rainfall generally continues for 8 hours. Okay, so very less rainfalls are there which continues for 8 hours. So this is a very long duration. So FC will be equal to 1.2 centimeter per hour. Okay, because after some time it is found that your infiltration capacity becomes constant, equal to 1.2 centimeter per hour. Yes, perfect. Now, and also they are saying if total infiltration during the 8-hour period storm was 15 centimeter, that means F in centimeter, total depth of infiltration is 15 centimeter, and time duration is 8 hours. Okay, they are considering 8-hour duration. Now, Estimate the value of decay coefficient in Horton's infiltration capacity equation. So can you find the answer to this one? Can you find the answer to this one? You are given F. F is given to you. F is given to you. Everything is given to you. You only need to find K. You have to only find K. Can you guess it? Can you solve it? I'm giving you 1 minute's time. Can you guess the value of K? Try to solve it. See, this is our basic equation. Okay, F is equal to integration Fc plus F naught Fc e power minus Kt dt. This is our basic equation. This is our basic equation, I guess. So, see, if I want to integrate it, are you able to solve it till now? Or should I tell you? Now listen very carefully. If you have to solve it, we have two methods. Okay, you can go by the basic method or one thing. See, this 8 hour thing is a very long time. Okay, if you will integrate this equation, how this equation will turn out to be? If I'm integrating it from 0 to t, this term will be fct. Yes or no? Fc multiplied by t. Yes or no? See, if this is 3, this is 3t. Similarly, this is fc into t. This is constant. Yes sir, this is constant. This is constant. So bring this constant out, and this, see, we have integrated this thing. Now we have to integrate the second term. In second term we have a constant which we have brought out. Now what I will do, I will write integration from 0 to t e power minus kt dt. Yes or no? Now what I have to do, I will solve this integration there. Now suppose listen very carefully, suppose this t is becoming very large. Let us assume t is very large and it is almost tending to infinite. Almost, let us say it is tending to infinite. So let us say if this t is tending to infinite, e power minus kt dt. So if I will integrate it, e power minus kt is e power minus kt divided by minus k, put the upper limit, put lower limit, put the value of t as infinity. E power minus infinity is 0. E power minus infinity is 0. Why? See, e power minus infinity is 1 upon e power infinity. E power infinity is infinity and 1 upon infinity is 0. You all know this thing. Okay. So this is 0 minus lower limit. Put 0. Anything raised to power 0 is 1. 1 upon minus k. 1 upon minus k. So this is 1 upon k. This is 1 upon k. So simply you need to understand, whenever this value of t is tending to be large, okay, let us assume this value of t is going very large. Let me write here, if t is very large, or let us say it is almost tending to infinite, then in that case, what will be my formula? The value of this integration will be equal to 1 by k. Yes or no? The value of this integration will be 1 by k. Then in that case, I can write the formula for infiltration will be, the formula for total infiltration will be fc into t plus f naught minus fc, which is constant, divided by k. The value of this is 1 by k. Okay, so this is our equation, but yes, one thing we have to make sure that this equation is only valid when your, see, this equation will give you good results when your time variable is large. Okay, otherwise this will give you certain error. So you can integrate it, or you can put this formula. See, in this f is given, fc is given, time duration, f naught, fc, everything is given. From here you can find the k value. Yes or no? From here you can find the value of k. So find it, use this value. Okay, so value of f is, value of f is 15 centimeter. Okay, f is 15. Fc is how much? Fc is 1.2 centimeter per hour. Fc is 1.2 centimeter per hour. Total time is 8 hour. Multiply by 8 hour. This is 8. F naught minus Fc means 6 minus 1.2. Put 6 minus 1.2 centimeter per hour. Divide by k. So what value of k we are getting from here? 1.2 into 8 is 9.6. Bring it here. R thing will get cancelled. 15 minus 9.6. Okay, 12 8 is 96. So this is good. 6 minus 1.2 centimeter per hour divided by kh. So kh is 6 minus 1.2, 4.8. This will go up, this will come down. 15 minus 9.6 is 5.4 centimeter. Centimeter will get cancelled. This is 6 8 is 48. 6 9 is 54. 8 by 9 per hour. 8 by 9 per hour answer is coming. So if you will convert it into decimal place, you will get it as 0.888, like this you will get per hour. Okay, yes, 0.889 like this you can get. So I hope the concept is clear to you. So what you have learned from here, basically sir, we have understood how to find the value of k in quick manner. Okay, so this type of question has been asked. See, if you will find this with the help of this entire equation, then also you will get the correct answer, but yes, it will take certain amount of time. Okay, then also you will get almost same value. So I hope this formula is also clear. You can note it down in your notes only, like when your you can write it down in your notes only, that whenever time is very large. Okay, see, you need to understand what is the difference between this question and this question. See, in this question the time duration is 30 minutes only. 30 minutes is less time. 30 minutes, next 30 minutes, 45 minutes. Yes or no? So you can write down, you can write that formula for f adjacent to this one, that whenever your time value is going very large, you can have the formula as, you can have the formula of f as fc into t plus f naught minus fc upon k. Okay, remember this whenever your value of time is very large. So I hope this is clear to you. So we'll stop here. We'll discuss phi index tomorrow. So this is the last question which we are discussing today. Okay, now we'll discuss the concept tomorrow. So I hope all the things are clear to you. Yes or no? Tell me if all the concepts are clear to you, then we'll end our class today. So basically in today's class we have discussed this infiltration thing, Horton's equation we have discussed, we have solved certain questions, we have discussed basically Horton's equation, and we have also discussed the methods of measurement of infiltration. We have discussed different kinds of infiltrometer. Okay, so with this we will end our class today, and we will catch up tomorrow with the concept of phi index. Okay, we'll discuss phi index tomorrow, and we'll continue with our next chapter. Okay, tomorrow. So infiltration is almost towards the end. Tomorrow we'll discuss the concept of phi index, and one more question from Horton's equation we'll discuss, which has been asked in your gate examination. That question we'll also take up, and after that we'll discuss phi index concept. Okay, so good night everyone, stay blessed, take care. We'll catch up tomorrow live with concept of phi index. Stay blessed.